So I wanted to make a quick video talking about linearizing data and what that means, or linearization, um, and how to go through the process using Excel so that we can pull some information off of our data set. This is going to be important in the lab. And the idea is that we can take some set of data and manipulate it so that it creates a linear trend, and that's our linearization part. And then once it's been linearized, so it's following a line, well, then we can do regression on it, a best fit line. That's not really a line, but you get the idea. So we can do regression, linear regression in this case, which will give us an equation of the form y equals mx plus b. And we can then find these constants of proportionality and y-intercept and stuff and interpret what these mean in terms of our situation. So that's the idea. We're going to take some data, make it into a line, do a linear regression, and we get these values out. Okay, so I'm going to go through two examples, a simple one and then a more complex one, of how to use Excel to do this. So here's Excel, and let's suppose that we were doing a lab where we were dropping a ball and just measuring the position. I guess I should do that as a y. Couple things. One, you can put all your data into Excel to do this type of manipulation, and then you can screenshot this and put it into Word when you write a lab report, as well as the graphs that we'll produce. And so what we're doing is we're just measuring how far it's fallen, from some distance. So we're measuring y positive is down is positive, so it's falling. And here's my time. So what we want to do is we want to graph this, and you have to be careful on how you graph it here because y is the dependent variable. And if you recall, on a graph, we always graph our dependent on the y-axis. So this is our dependent versus our independent variable here. And so in this case, the y, the position, needs to be on the vertical axis, and the time would be on the horizontal. That's my independent. I'm just going to label that real quick. So this is dependent and this is independent. Okay, so creating graphs in Excel is pretty easy, but I'm going to show you one thing you got to keep in mind. So in this case, we typically will write our dependent, our x and y in that. And so anyway, you got to pay attention to the order. Let me show you what happens. If I highlight this and then I go to insert, and then I'm looking for Scatterplot. So that's over this little drop down. And we always do a Scatterplot. Don't do one with a line on it. But what's happened here is that my variables are graphed backwards because I can see like this goes to 240. So the y has been graphed along here. That's around 240, whereas my time is here. And so we want to flip those. And so there's two ways to do it. One way would be just to flip this. So just move this column over. So make sure you always have independent and then dependent. And then life will be good. So I'm going to delete that. Now I'm going to walk you through the steps again. So I have my independent and dependent on the proper, the left and right. So we just highlight the data. And we're going to go to insert and then Scatterplot. And then we select a scatter. Okay, so now we have a graph. And the problem is that this is not linear. I can see that it's bending upward. So I can't get any information directly off of it. But what we're going to do is we're going to linearize it. I wanted to talk a little bit about the graphs though, because I said, you can put these into your lab report, which would be a good idea for data analysis. So there's some things you would edit here. And if you're using, I know you guys are on Mac. I don't have Mac, but if I just click this, it gives me different things that I can put, like the axis titles, which I would want to do. We would label this according to whatever I was doing. This would be position in meters versus time in seconds. And then we label our graph, our axes as well. So this one would be position, meters, and time. Well, you get the idea. I don't know what's going on. Okay, time, in seconds. Something like that. Make it look nice. You can also go up in this design up here. Don't do these. Just keep it nice and clean. We don't need any blue graphs or anything like that. It just gets distracting for the reader. So you keep it clean. I would just use the default. But we don't want to use this graph. So you would probably show this and say, well, I don't have a linear trend, so therefore I'm going to linearize my data. And since this is quadratic, then it's probably, what we're going to do is we're going to square all of the times. So we square the independent variable for this because it's a parabola. So I'm going to take all of these and square them, and then I'm going to plot these versus t squared. Okay, so let's do that. So what I'm going to do is I'm just going to copy this data into a new table. And now instead of t, what I'm going to do is put t squared. And now I need to calculate these. Oops. Sorry. Hold on one second, because I have these as a formula. All right, now I can change these. So what I want to do is I want to just take all of my times from up here and square them. And so we're going to tell Excel, and we tell Excel to do a calculation by entering an equal sign. So we're going to begin with an equal sign. And then I'm telling it, okay, take this cell, which is A3, and square it. So we're going to raise it to the second power and hit enter, and it's 0. Okay, not very interesting. Okay, you don't have to type it again and again and again. Instead, what we're going to do is we're going to fill it all the way down, and Excel will automatically increment it according to up here. So it'll all work out. So what you do is you hover until you're on this little box in the corner, and you'll see your cursor changes. Like it's a big white cross, and now it's a little black cross. So then I grab and drag, and it's going to fill it down. So I can check, and I could say, okay, well, the first one would be 1 squared is 1, 2 squared is 4, 3 squared is 9. Okay, good. So these are all the squared values. Now we're going to plot it. So now we're going to plot y versus t squared. So again, we'll just highlight it, and then we'll insert a scatter plot. I'm going to drag it down, and now it looks like a line. That looks pretty linear. So now we can analyze it. I'm not going to go through and add all the chart stuff, but that's what you should do. Instead, I'm going to show you the second part. Once we have our data in a line linearized, now we have to do a regression on it. And so the easiest way to do that, sorry, I got a phone call. I don't remember where I was. Regression. Okay, so what you do is if you just go over one of your data points and do a right click, then it'll bring up this menu. And what we're going to do is we're going to add a trend line. So add trend line. And then it's going to open up this window over here. So you see there's some different regressions you can do. We're just going to do linear. And then we want to go down, and we want to set, we'll leave that alone. We'll just say display the equation on the chart and display the r squared value. We want both of those. I'll explain what they are. So you can see it gave me an equation. Can't make it bigger. Stinking thing. Okay, anyway, it says y equals 4.9x. Now for our case, that would be y equal to 4.9 times t squared. So what we can do is we can get information from that. So my equation, the equation that I got through regression is y equals 4.9 x, but then we change it into the variables that we're using. Well, we're using y for position, and then we graphed it versus t squared. And then from there, I can try to figure out, well, what's this 4.9? And we should recognize that that's 1/2 of the acceleration due to gravity. And that's what we would expect. So we've shown like, that it follows constant acceleration. Anyway, this was contrived. I made it up, but I'm going to try a more complicated one now. So there's 2 steps. One was taking our data, seeing what it looked like, and then linearizing the data, and then doing a regression. The r squared value is how well the trend line fits to the data. 1 is perfect. 0 is no fit. So if I change some of these, like let's do 4.6, 19.8, 8, 46. You can see how the R value dropped because I have a data point that's not on the line. 70, 120, let's do 190 and 250. So even here, you see it's not as clean, and that's what this over here. I should have a 0, 0, but anyway, my R squared is still 0.99, so that's good. If you're above 0.7, it's good. Don't worry too much about this. It's the equation that we want. So here's a more complicated example. I was using this FET just to gather some data. So this is investigating the force of gravity between two objects that have mass. I did some different masses, and then I did 5 different distances for each of those masses so that I could investigate what's going on. So I've already gone through and put the data in. So what you can see is I had 5 trials with the same mass at 5 different distances, and I recorded the force. Then I changed the mass and again recorded 5. You really want 5 or more data sets to do regression. So now we're going to get to graphing. So the question is, well, what I'm trying to do is find big G. So say I was, I know that Newton's law of gravity says that the gravitational force is equal to big G, m1 times m2 divided by r squared. And I want to know what's G. So we collect data for these things. We change them around, get a bunch of data, and this one, and then we linearize it. So to linearize it, what we're going to do is we want it to look like y equals mx. That would be a line. And then my slope would be this constant. So that's the goal. So basically what I'm going to do is I'm going to let this big quantity be my x value, and then I'm going to graph it, and then the force would be my y. So we're going to create a new data table that has this, mass times mass divided by r squared, and then we'll graph the two, and it should create a line, hopefully. Otherwise I wasted your time. Okay, so we're going to do a new table. Force is my dependent, and then all this other stuff is my independent. So we're going to copy this. And I'll just put it here. And then we're going to do m1 times m2 divided by r squared. Okay. So Excel's nice because you can just click around to do this math. So we're going to start it with an equal sign. So equals. And I need mass 1. So we just click on the very first data set, mass 1, and then I'm going to do times mass 2, and then we're going to divide it by r raised to the power 2. Now be careful here because you see how I have a multiplication and division. We got to be careful and make sure that it's doing the order of operations correctly. So I definitely want that product on top, so just throw it in parentheses. It may do it right, but now I guarantee that it's going to do it right. So there's what I get. I get this value, 625. That's this mass times that mass divided by this squared. So again, now we can just fill it. So just go to the corner, drag it down. So now I get all these values. Okay, the whole reason of doing this was so that I could plot it. So here's what we're going to do. We're going to highlight the data, and then we're going to go to Insert, Scatterplot, and put my Scatterplot in there. I have one value that's way off. Oh, right here. You see this? You see how I have an outlier, and so everything laid down because of the scale. So we need to change that one. I mistyped that one. That's 1.04 e negative 8. So now I need to recopy this data. There we go. That looks pretty linear to me, right? Okay, so now what I want to do is, you can see those are my forces because they're e to the negative 8, so everything's plotted correctly. So now what I want to do is a regression. That's the second part. So you right-click on one of the data points, add trend line. Once it comes up, we're going to do a linear. I want to display the equation, and I'll set the r squared value. So you can see I got 7 times 10 to the negative 11 minus 4 times 10 to the negative 11. So this right here comes from experimental uncertainty and error. You can see the r squared, though, it's 1. So we've linearized it. So I know that it has this form. It's in a line. And so the slope of that line would be my big G. And it says the slope is 7. I'll write it over here. It says 7 times 10 to the negative 11. That would be my G. Now, how close is it? It's actually like 6.907, I think. I don't know. It's that's it. What's happening is Excel is rounding it, but that's big G. So this is how we linearize data, and then we do regression in order to find constants like this, where we're running multiple trials and changing variables to figure out some constant. So that's it. I hope it helps. If you have any questions, just ask.